Game theory dominance strategy, and I discussed about dominance strategy uh, in the last class, where I set some rules by which this particular thing can be studied. Some theory has been discussed. I gave you one statement of the theorem, but problem has not been done. So today I'm going to consider one problem for making you to make you understand what dominant strategy works. So I'm choosing a problem from the book of the book which I have shared with you. So let us select let us select a game matrix. Let us select a game matrix which is given by uh, let us name it as capital G. We have player A. Player A is called the maximizing player, you know, and the strategies of player A are uh, Roman 1, Roman 2, and Roman 3. Three strategies are for player A, and the strategies for player B are Roman 1, Roman 2, Roman 3, and Roman 4. These are the strategies for player B. Uh, let us name those strategies by primes. Okay, some sort of game is there. Don't ask me what this game is. It's just a game. This particular game has been chosen for the sake of understanding of the problem. I mean, how to deal with the problem. Maybe this particular game doesn't have any practical significance or practical relevance. Just for understanding of the mathematics, how to apply dominant strategies to this particular matrix, and the values given are 10 and 0, 7, 4, 2, 6, 4, 7, 5, 2, 3, 8, 5, 2, 3, 8. Okay, so this is the matrix. Now, first of all, let me remind you something. Why do we use dominant strategy? Why do we use dominant strategy? Okay, why do we use it? In the last class, I talked about algebraic method. In algebraic method, we have seen that if we are given a game matrix of order 2 by 2 of this form, then we can find out the probabilities p1, probabilities p, and 1 minus p for player A, and we also can find the probabilities for player B, q and 1 minus q. And not only this, we can also find the value of the game. But we have to keep in mind that provided, this is very important, and I'm again saying this thing to you, provided uh, the game is a mixed strategy game, otherwise not. Game is a mixed strategic game, then only this can be applied. Game is a mixed strategic game. Now the game is mixed strategic when the game is mixed strategic. When the game is mixed strategic, it is when uh, von Neumann maximin and minimax criteria is not applicable. Maximin and minimax criteria is not applicable. Okay, and then if we check it that it is not applicable, then the game is not pure strategic game. The game is not a pure strategic game. And then we try to find out the mixed strategy of the game, and I've shown you that if the matrix is of order 2 by 2, then we can apply an algebraic process to find the probabilities associated with player A and probabilities associated with player B, where these probabilities are actually called the mixed strategies. So P1 minus P is the mixed strategy for player A, and Q1 minus Q is the mixed strategy of player B. Okay. Question is, if the matrix is of the, now the important portion is, if the game is not pure strategic, and also it is not of order 2 by 2, it is not of order 2 by 2, then how can we make it, if it is, if there are some rules by which a matrix can be made of order 2 by 2, and if the matrix can be made of order 2 by 2, then we can apply this particular formula. So that's why, to reduce the size of the matrix to a 2 by 2 form, we apply dominance strategy, and sometimes in some books it is known as dominance principle. Now, what are the principles? If you can recall the theorem, in the theorem it is mentioned that, in brief I'm writing, in very brief sentences I'm writing, that it is mentioned that in dominance principle, point number 1, dominated rows are deleted and dominating columns are deleted. And when we call, we say that a particular row dominates the another row. The row 1, say row X, dominates row Y if each element of Y is less than or equal to each element is less than or equal to corresponding element of, not each element, corresponding element of row X. So if this is so, then we can say that, yeah, this thing is happening. I mean, a particular, if every element of a particular row is less than or equal to the corresponding element of another row, then the row Y is called the dominated row, and we shall try to erase the row Y, that is dominated row, from the picture, from the matrix. This happens for row. Okay. And when we say a column is dominating, now I have to go to the next page to write this. Okay, I think I can erase this portion because this portion you already know. So I'm trying to write over here. Okay, so when we say that this a particular column is dominated, when similarly when if, no, let us write it in this way. If Z is a column and W is a column, and each element of Z is greater than or equal to corresponding element of W, then we say that Z is the dominating column. We say that Z is the dominating column, and we try to erase Z from the picture. So we shall try to look for these things in the given matrix. Okay, So if you carefully observe, you will find that if I have observed this particular, if I look at this particular column, you will see that this column is having the element 0, 6, 2. And if I look at this column, I will see that this column is having elements 4, 7, and 8. Now, I have not done it suddenly. Before taking your class, I have already checked. I have already checked this. I have compared each and every column with one another, and I have found that already I have found that instantly I cannot see, because I have to see that, yeah, I am searching for such columns where these things are happening. Now, since I'm taking your class, and if I search and if I show you that how am I searching, then it will kill time. So already I have searched, and I'm showing you that this, my search result gives me that this particular column is having element 0, 6, 2, and this column is having element 4, 7, and 8. And this searching takes time when the number of matrix, size of the matrix is too big. So it's a kind of analysis, and it takes time. You will see that if I try to compare this, you will see that this element 4, try to compare this with that element, and you will see that 4 is greater than 0. The element 7 is actually greater than the element 6, and element 8 is actually greater than the element 2. So we can now say that each element of column 4 is dominating corresponding element of column, uh, each element of column 4 is dominating corresponding element of column 2. Previously, here I wrote each element of y is less than or equal to correspond each element of x. Don't say like this. Don't say that each element of column 4 prime is dominating each element of column 2 prime. The word should not be each, because you see 4 is dominating 0, but 4 is not dominating 6. And so it is happening, if 4 is here, then this row, in this row, the two elements are present, 4 and 0. With respect to column, they are in different columns, but with respect to the row, they are in the same row. So it will correspond to its corresponding nemesis. It will dominate its corresponding nemesis. It will dominate its corresponding nemesis. So this word should be corresponding. Now, once it is happening and you can find it out, then you will say that, yeah, okay, then my column 4 prime is dominating column, and therefore I can erase the dominating column from the picture in the further matrix. Okay, so we shall write, observing the given game matrix G, we find that each element of column 4 prime is dominating corresponding element of column corresponding element of column 2 prime. And so in that case, column 4 prime is dominating, and hence can be neglected or can be erased, so that the new matrix is G prime, and that is, so I'm not writing the, okay, let's write it, because it is the first problem. So let me write all the strategies. So we have this. So the new matrix becomes 1, 1 prime, 2 prime, 3 prime. All these primes are there, and the The matrix will be 10, 2, 5, 0, 6, 2, and 7, 4, 3. So the size, now you see the size of the matrix is 3 by 3. Then we shall try to look at the matrix further, and we'll try to look at this, and we'll try to find out whether any row is dominating any other row or any column is dominating any other column. If we carefully observe, we will find that, suppose I'm comparing the row 1 and row 2. Now you see 10 is greater than 2, but 0 is less than 6. So no way this 1 and 2 can be compared. We cannot compare this 1 and 2, because here this is dominating that, but here that is dominating this. So it is not happening with respect to 1 and 2. If we compare 1 and 3, then 10 is dominating 5, but again 2 is dominating 0. So it is also not happening for 1 and 3. And if I try to compare 2 and 3, then you will see that 5 is dominating 2, but 6 is dominating 2. So it is in the opposite direction. So it is also not happening for rows, for any rows. So we see that this observation, my first observation is there is no rows which dominate the other. Okay, so we can do the same thing for columns. So let us write the matrix once again. So the matrix was this. In the examination, you don't have to, and since you are sitting for online examinations, so you don't have to worry much. So I don't know how the questions will be set. I do not have any idea. So, but if this examination were a offline examination, then you could have done this analysis very carefully. So I'm writing this matrix once again, and now I'm trying to compare the columns. Now you see, if I compare these two columns, 10 is dominating 0, but 2 is dominating 6. So it is 2 is not dominating 6. 2 is being dominated by 6, and so it is 1 prime and 2 prime are not comparable. Here 10 is dominating 7, but 4 is dominating 2. So it is also not comparable. And here 7 is dominating 0, but 4 is being dominated by 6. So it is not. So my second observation is that, and also there is no column which dominate the other column. Okay, so the theorem says we are not able to find, according to the theorem, as the theorem says, we are not able to find any dominated row or dominating column. But there is another portion of the theorem which says that there might be some convex combination, of rows which can dominate the other row, or there might be some convex combination of column which may be dominated by another column. Okay, so we have to analyze this particular thing. So for this portion is very important. So for this, what we need to do is that, again, you have to go for a very long analysis. But since for this particular problem, I'm making the thing easier for you. But if the problem is unknown, then you have to give some time to analyze the situation. Now you see that if I look at this particular matrix elements, here 10 and 2 is there, 0 and 6 is there, 7 and 4 is there. Now you see that if I take some multiple of 10 and 2 and we add them together, okay, then it may dominate 5. So we must find out that multiple. If I take the multiple of 0 and 6, it may dominate 2. So we have to get that multiple also. If we take the multiple of 7 and 4, we have to take that may dominate 3. I'm actually guessing that by looking at the elements, the size of the elements. So we consider a scalar lambda which lies between 0 and 1, so that these three things may happen. What are they? First of all, lambda into 10 plus 2 into 1 minus lambda. Okay, that can dominate 5. Second, what can happen? Lambda into 0 plus 6 into 1 minus lambda can dominate 2. And lambda into 7 plus 4 into 1 minus lambda can dominate 3. We have to actually solve these inequalities. Our next job is to solve these inequalities to check if there is a possible limit of lambda for which this may happen. But after solving this inequality, if we reach at some absurdity, then we shall have to neglect these inequalities and we have to consider further something else. So let us just check. Then we have to consider the convex combination of the strategy 1 and strategy 3, and to find whether that convex combination dominates strategy 2 or not. So actually it is very time taking and it's very difficult. This analysis is very difficult. It's not very easy. Okay, so it's very difficult. So I am trying to analyze this particular, I'm trying to solve this inequality, and let's see what comes out of lambda. So first of all, I'm taking this from inequality 1. From inequality 1, we get what we get, 10 lambda. Okay, let us write it once again. 10 lambda plus, what was that? 2 into 1 minus lambda. 2 into 1 minus lambda, that must be greater than or equal to 5. Let us solve it. So we get 10 lambda plus 2 minus 2 lambda. This should be greater than or equal to 5. Then we are getting 8 lambda plus 2. This should be greater than or equal to 5. Then 8 lambda greater than or equal to 3. And we are getting lambda is greater than or equal to 3 by 8. Okay, that is my number 1. From inequality 2, what we are getting? From inequality 2, we are getting lambda into 0 means 0. So 6 into 1 minus lambda greater than or equal to 2. 6 into 1 minus lambda greater than or equal to 2. So we are getting 6 minus 6 lambda greater than or equal to 2. And that is 6 minus 2 greater than or equal to 6 lambda. And that is 4 greater than or equal to 6 lambda. And 4 by 6 greater than or equal to lambda, or 2 by 3 greater than or equal to lambda. That is number 2. And from inequality 3, what we are getting? From inequality 3, we are getting, okay, what was that? 7 lambda plus 4 into 1 minus lambda. 7 lambda plus 4 into 1 minus lambda. This should be greater than or equal to 3. This should be greater than or equal to 3. So this implies 7 lambda plus 4 in minus 4 lambda greater than or equal to 3. This implies 3 lambda plus 4 and that is 3 lambda 3 minus 4, and that is 3 lambda greater than or equal to minus 1, and that is lambda greater than or equal to minus 1/3. Now you see that 3 by 8, this term is positive term, and minus 1/3 is negative term, and obviously minus 1/3 is less than 3 by 8. So since minus 1/3 is less than 3 by 8 and lambda is greater than or equal to 3 by 8, so obviously lambda should be greater than or equal to minus 1/3. So we can consider this into consideration, and here we are finding that lambda is less than or equal to 2 by 3. Now 3 by 8 means how much? Okay, let us check it. 3 by 8 means 3 by 8 means decimal representation. In decimal representation, 3 by 8 is 0.375, and 2 by 3 is 0.66. 2 by 3 is 0.66. So obviously, we find that from this and that combining, let us name it as 1 and let us name it as 2. So combining 1 and 2, we find that lambda is lying between 3 by 8 and 2 by 3. So what does it mean? That it is possible to find such lambda for which convex combination of this Roman 1 and Roman 2 dominates Roman 3. So it is possible to get one such lambda. We get many such lambdas, lambda lying between 3 by 8 and 2 by 3, so that convex combination of 1 and 2 dominates convex combination of 1 and 2 dominates 3, and therefore so Roman 3 is dominated row. Roman 3 is dominated row, and we can erase it. So my new matrix become, therefore the new matrix becomes G prime double prime, and we are writing it as the two strategies 1 and 2, and B is having only 3 strategies 1, 2 prime and 3 prime. That is for B. And what are the values? 10, 0, 7, 2, 6, 4. The matrix size is reduced further of order 2 by 3. Okay. Now there is no such. Now you see that again you are to compare the rows. Now you see that this particular element is dominating that element, but this is being dominated. So these two rows are not comparable. So we can do the same thing with column. So again we see that 10 dominates this, 10 dominates this, but this is being dominated by 2. So 1 prime and 2 prime are not comparable. Similar is the case with 1 prime and 3 prime. 10 is greater than 7, but 2 is less than 4. This always not happens. So it depends upon the matrix. Now again I am making the things easier for you, because the thing has already been analyzed, that I am going to check, is there any such lambda for which the convex combination of these two is being dominated by the corresponding values of Roman 3 prime. So let us try to find lambda, so that 10 lambda plus 0 into 1 minus lambda is less than or equal to 7. 2 lambda plus 6 into 1 minus lambda less than or equal to 4. Let us solve these inequalities. Okay, so from there we are getting 10 lambda less than or equal to 7. So lambda is less than or equal to 7 by 10. And from there we are getting 2 lambda plus 6 minus 6 lambda less than or equal to 4, which is minus 4 lambda plus 6 less than or equal to 4, which implies minus 4 lambda less than or equal to 4 minus 6, that is minus 2. And if I divide both the sides by 2, both the sides by 4, sorry, minus 4, so the inequality sign will change and we will get lambda greater than 2 by 4, which is equal to half. So lambda is greater than or equal to half. Now half is 0.5 and 7 is 0.7. So comparing these two, we see that such lambdas exist so that lambda lies between half and 7 by 10, and column 3 prime is dominating column. So we can omit 3 prime, and the matrix reduces to G triple prime, which is player A having the 2 strategy 1 and 2, player B having the 2 strategies 1 prime and 2 prime, and the order of the matrix now becomes 2 by 2. Once the matrix order becomes 2 by 2, once the size of the matrix becomes 2 by 2, we can apply over the algebraic method, which I discussed in the previous class. You can find the probabilities. You can find the probabilities with the formula which I derived in my earlier class. Okay. I'm not writing the formula because you just go through my previous videos and you'll be able to find what the formula were, and probably in your copies also the formula were present. You write your roll numbers in the chat box, okay, because time is running out and I have to take the attendance. So you see, so this is the analysis. This is all about this analysis of this dominance strategy, the dominance principle. And if you have any queries, you can ask me, but this analysis is a quite large, quite long analysis, and it is not that easy. Okay, so I have made the things short, but you have to observe it. It's very time taking, and the way it is done in the book, okay, in other books, the process is not correct. Actually, this analysis is a very time taking analysis. So this is all about dominant strategies. You can take other problems from the exercise, any book. You can, if you're studying organizer now for just to save your time, then it's okay, no problem. You can take one problem from the organizer or any other comfortable book, and any other book which you are comfortable with, okay, to just save time. And you try to apply this logic over there. I mean to say, do not learn anything from those books. Take the problem and do it in the way as it is being shown in the class. Okay, so that is all about dominance principle. Tomorrow, I can, if I suddenly ask you to, if I want to take one class of yours, say at this hour, at 3:20 or etc., like that, will it be possible for you? Because these notifications will be sudden. I mean, whenever I get the time, I can ask the CR to just inform you to be online.
Sir, tomorrow is not possible. We having mock test of Macaut from 3 to 5. So this time we will be engaged.
Oh, acha. So okay,
tomorrow
then
day after tomorrow সোমবার আছে
কি আছে?
স্যার মক টেস্টটা সোমবার